Hi guys, I hope that you're all doing well. Still under Algebra. Today's lesson is about factorization and we'll be learning the difference of two squares. This is grade 9 work and I told you guys to check out the grade 9 factorization playlist first as I do more examples there. So what does the difference of two squares mean? To understand it, let's break it down. You have the difference first, right? When you see the term difference in mathematics, you should know that it means subtraction. So you have to think of a minus sign. The difference of two means that there should be exactly two terms. Okay, then the squares term means that both terms, remember we're talking about two terms, both terms should be perfect squares. So you should basically have two terms that are perfect squares that are separated by the minus sign. That is what the difference of two squares means. So to ensure that we have the difference of two squares, there's a checklist that I made on the right hand side. You have to meet all these conditions, otherwise you don't have the difference of two squares. Firstly, are there exactly two terms? It's said here, difference of two squares. So there should be two terms as I've said. Are the terms separated by the minus sign? It's here. Remember, there should be a difference, meaning a minus between those two terms. Lastly, are they perfect squares? If they are imperfect squares, then you don't have the difference of two squares. Now let me explain what a perfect square is. So a perfect square is a number you get when you multiply a whole number by itself. For example, 9 is a perfect square, as you have to multiply 3 by 3. 16 is also a perfect square, because you have to multiply 4 by 4. If you still don't get what I mean, the easiest way to understand this is that when you put a perfect square under a square root, the answer should be a whole number, meaning you shouldn't have remainders. For example, let's say 16, right? If you want to find out whether 16 is a difference of two squares, we can put 16 under a square bracket. Remember, there's an invisible 2 there. The square root of 16 is equal to 4. And if you want to remind yourself of the laws of exponents, remember I said they are very important in algebra. So just to remind you, when you have a square root and you want to answer, you have to say inner over outer. So this is basically 16 to the power 1. You know there's an invisible 2 there, as well as an invisible 1. So we have to write our base, which is 16, then inner over outer. 16 to the power 1 over 2. 16 to the power 1 over 2 is 4. That is how we break roots in mathematics. So you don't really have to do this. You can just punch this in your calculator. However, I'd recommend doing it in this manner so that you always remember your laws of exponents. It'll help you in your exam as you'll be tested on different laws. And the roots one is quite easy to forget, so I'd recommend that you practice it consistently. But you don't have to worry, I'll do more perfect squares examples. Now let's start with the first example. Let's try x squared minus 49. We have a checklist on the right hand side, right? What's the first condition? Are there two terms? We have x squared and 49. Remember, terms are separated by the minus sign. So we have term 1 and term 2. Yes, we do have two terms. Are the terms separated by the minus sign? You have a minus sign there. Yes. So we've met this condition as well as that one. And lastly, are they perfect squares? Is x squared a perfect square? If you're uncertain, you can always try this under your square root. This is why the square root is important, because you can really punch x squared in a calculator. So we have a square root x squared. Remember, there's an invisible 2 there. So we have to write our base, which is x, then inner, which is 2 over outer. 2 over 2 is equal to x. 2 over 2 is equal to 1. So it's basically x. Guys, if it weren't 1, let's say we had 1,8 or something, this wouldn't be a perfect square. After you break your root, you should have you should have an exponent that is a whole number. Okay, so this is x to the power 1. X squared is a perfect square. I'll do so for the first terms in this video. So 49, is it a perfect square? We can try putting it under a square root. We're solving for 49, right? 49, you have an invisible 2 as well as an invisible 1 raised to the power 1. To break our root, we have to write our base, which is 49, then inner over outer, which is 1 over 2. This is 49 to the power 1 over 2. 49 to the power 1 over 2 should give you 7. So 49 is a perfect square. As you don't have a remainder here, it's a whole number, it's just 7. So yes, they are both perfect squares. Both terms are perfect squares. So to solve this, we have to firstly find the square root of both terms. We've done this, right? You can do this on the side again. It's x squared. We put it under a root. The square root, it's inner over outer, which is x to the power 2 over 2, which is just x. So you have to open a first bracket and write down the square root of the first term first. We have x squared. Then a minus sign and the square root of 49. How do you solve this again? It's the square root of 49 to the power 1. You have a 2 there. So you write our base, which is 49 to the power 1 over 2. Inner over outer. 49 to the power 1 over 2 should give you 7. So we should have a 7 here. You've written down the square root of the second term. In the second bracket, you have to write down the same terms. We started with x plus 7. In the first bracket, you should have a minus, and in the second bracket, you should have a plus. However, you can also flip them. It could be a plus here and a minus there. The order doesn't really matter as long as you have opposite signs. So the answer of x squared minus 49 is x minus 7, x plus 7. You factorized at this point, and remember, you've done products, right? So distributing this like that, as you've done in the previous videos, should give you that. If you want to make sure, we can just distribute this. We'll say x times x, which is x squared. Then x times positive 7, you have plus 7x. Then negative 7 times x, this should be minus 7x. And negative 7 times positive 7, this should give you a negative 49. Let's look for like terms. You have x squared, you have 7x minus 7x. You're left with negative 49. Can you guys see that this is exactly like that one? I'm moving to the second example. Guys, if you don't understand this, you really need the grade 9 factorization videos. I introduce the concept and I do a lot of examples. So in grade 11, we just do a few of these examples. However, they are different. In this first example, we have the basic variable and the constant. The constant is this term. In the second one, I'll do one that has multiple coefficients as well as variables. Let's move to the second one. This video was brought to you by Spotify. Whether you love discovering new music, listening to podcasts, or creating the perfect playlist, Spotify has something for everyone. With the free version, you can enjoy millions of songs anytime, anywhere. Want the ultimate experience? Upgrade to Spotify Premium to enjoy ad-free listening, offline downloads, unlimited skips, and even better sound quality. No interruptions, just non-stop music and entertainment wherever you go. Download Spotify today and start listening to music your way. Let's try 16a squared minus 25b squared. What are our conditions again? Are there two terms? Term 1, term 2 separated by the minus sign. Yes, we do have two terms. Again, are the terms separated by the minus sign? I've already answered that. Yes, because there's a minus sign there. Lastly, are they perfect squares? There's only one way to find out. Let's try 16a squared. We're doing this on the side, okay? So it's 16a squared. We can put this under a square root. 16a squared. There's an invisible 2 there. So we start with the coefficient, which is 16. You write down your 16. Remember, it's 16 to the power 1. That is the exponent for 16. So it's 1 over outer, which is 2. We move to the variable. We have a, which is a to the power 2 over 2. We are breaking the root. You know this from the exponents videos. So 16 to the power 1 over 2 should give you 4. Let's move to the variable. We have a 2 over 2 is equal to 1. So the square root of 16a squared is 4a. Therefore, this is a perfect square. We don't have remainders here. Let's move to negative 25b squared. So we just take 25b squared as it is, put it under a square root, 25b squared. How do we solve this again? Inner over outer. We start with the coefficient. It's 25 to the power 1. This is an invisible 1 over 2. The outer right. Let's move to the variable. We have b 2 over 2. 25 to the power 1 over 2 should give you 5. b to the power 2 over 2 should give you 1. Therefore, this is also a perfect square. The square root of 25b squared is 5b. So we do have perfect squares. How do we solve this again? We should have two brackets. And you start with the square root of the first term. 16a squared, we said that it's 4a. We can have a minus sign, right? The square root of the second term, 25b squared, it's 5b. Then 25b squared, 16a squared, the square root is 5b. It's 4a. Plus, remember you change the sign, 5b. So you should have 4a here and 4a there, 5b here and 5b there. However, the signs should be different. Whether it's a plus here or a minus there, it doesn't matter, as long as they're opposite signs. Therefore, your answer is 4a minus 5b times 4a plus 5b. Let's do the third example. Let's try x to the power 4 minus 81. Our conditions, are there two terms? Yes. Are the terms separated by the minus sign? Yes. Are they perfect squares? Yes. X to the power 4 is a perfect square and 81 is a perfect square. So let's try to factorize this. We have to find the square root of the first term, right? Just to be certain whether it's a perfect square. So we'll have x to the power 4. We put it under a square root. We should get x to the power inner over outer. 4 over 2. X to the power 4 over 2 should give you 2. So it's x to the power 2. Now let's move to the second term. We have 81. 81 is equal to 81 under square root. The exponent is obviously an invisible 1. So this should be 81 to the power inner over outer, 1 over 2. 81 to the power 1 over 2 should give you 9. So in the first bracket, we should have x squared and 9. Let me minimize this. Open the first bracket, we have x squared minus 9. And in the second bracket, we should have x squared plus 9. Same terms, different signs. So are we done factorizing? We have x squared minus 9 and x squared plus 9. No, because you also have a difference of 2 squares there. So we can factorize further. We take the same steps. This time we're solving for this bracket. So always make sure that you factorized until you can't factorize anymore. Let me do this under. We have x squared. Put it in the square root. X squared, that's an invisible 2. So it's x to the power 2 over 2, which is x to the power 1. For this term, we have 9. We put it under square root to the power 1. So we get 9 to the power inner over outer, 1 over 2. 9 to the power 1 over 2 is 3. So in the first bracket, we should have x and 3. First bracket, we have x minus 3, x plus 3. However, we still have this bracket that we have to account for. So just write it next to the first two brackets. There should be x squared plus 9. So you fully factorized. We have x minus 3, x plus 3, x squared plus 9. Is this a difference of 2 squares? Let's check. Are there two terms? Yes. Are the terms separated by a minus sign? No, there's a plus sign. So you haven't met that condition. Therefore, we don't have the difference of two squares. Now let's do the fourth example. Let's try the fourth example. You have 3x cubed minus 12x. Let's check our conditions. Are there two terms? Term 1, term 2? Yes. Are the terms separated by a minus sign? Yes. Are they perfect squares? We have 3x cubed, which isn't a perfect square, minus 12x, which also isn't a perfect square. So guys, when you factorize, the first thing that you should do is to look for the common factor. Normally, you want to find the common factor, and I taught you guys how to factorize that, right? I think it was in the first video. So that's what you always want to do. We can try to take out a common factor. 3x cubed minus 12x. You guys should know this. What is the highest common factor? 3 and 12 can both be divided by 3. Therefore, the HCF is 3. We have an x here and an x there. You have x to the power 1, right, in the second term. So we take the variable that has the lowest power. Between x cubed and x to the power 1, which one has the lowest power? It's obviously x to the power 1, or it's just x. So we can only afford to take out x. Let's open our bracket. Now we have to divide every term with 3x, what we have outside the highest common factor. So 3 divided by 3 is 1. You don't really have to write down that 1. Then we have x cubed. Can you guys see? So this is basically x to the power 3 or x cubed divided by x. Remember, we say 3 minus 1, which is 2. So we should have x squared here. Now let's move to 12. We start with the coefficients. 12 divided by 3 is 4. However, it's negative 12. Don't forget the sign. Negative 12 divided by positive 3 should give you a negative 4. You have an x divided by x. These cancel each other out, and you're left with 1. So it's just x squared minus 4. So can you guys see that this looks a bit familiar? It could be the difference of two squares. Let's check inside the bracket, right? Are there two terms? Term 1, term 2? Yes. Are the terms separated by a minus sign? We have a minus sign there. Yes. And lastly, are they perfect squares? Guys, you have x squared. By now, you should know that it's a perfect square. We also have 4. It is a perfect square. So how do we solve this again? We can try to solve for x squared by putting it under a square root. I know this is a necessary step, but I want you guys to remember how we solve roots in exponents. So this is x inner over outer 2 over 2, which is x to the power 1. Now let's move to 4. We put our 4 in a square root, excuse me. So this is 4 to the power 1. We write our base, which is 4 inner over outer 1 over 2. 4 to the power 1 over 2 is 2. So in the first bracket, we should have x. And in the second one, we should have 2. Please make sure that you have this in your notes, though. So we still have our 3x. It's 3x. The square root of x squared is x. Minus the square root of 4 is 2. In the second bracket, we have the same terms, x. However, the sign changes, x plus 2. So our final answer is 3x. In your brackets, you should have x minus 2 and x plus 2. Let's do the last example. Number 3, we have x plus 1 squared minus 16. What are conditions again? Are there two terms? We have term 1 and term 2. Are the terms separated by minus sign? Yes, that's the minus sign. Lastly, are they perfect squares? We aren't really certain about the first term. Let's try to put it in a square root. We have a square root here, x plus 1 squared. You know there's an invisible 2 there that you have to write. So it's inner over outer. We want to break this root. So we write our x plus 1 to the power 2 over 2, which is x plus 1 to the power 1. So it is a perfect square as it doesn't leave a remainder. So even though this looks a bit funny, you should be able to spot the difference of two squares anywhere. Firstly, you start with the common factors I've said. If it doesn't work, you move to other factorization techniques. So as you do more examples, you'll be able to spot them. The first term is definitely a perfect square. What about the second term? We have 16. We put it under a square root, so it's 16 to the power 1. There's an invisible 2 there. So this should be inner over outer to the power 1 over 2. 16 to the power 1 over 2 should give you 4. So they are perfect squares. Both terms are perfect squares. So we meet all the conditions. How do you factorize again? We need two brackets, right? In the first bracket, you should have a minus sign, in the second one a plus sign. Or we could have a minus sign here and a plus sign there. So for the first term, x plus 1 squared, the square root of this is x plus 1, the one that we solved. For the second term, we just have 4. So this will look like this. You have the first bracket, you have x plus 1 minus 4, which is the square root of the second term, right? Then a second bracket, we have x plus 1 minus, plus 4. Same terms, however, you have a different sign here and there. So can you see that this looks a bit confusing? We can try to set up square brackets so that it's a bit more clearer. Let's start with the first square bracket. When you have more than one bracket, in an expression, you can use square brackets. You have a square bracket, the square root of this, you said that it's x plus 1, minus the square root of 16, which is 4. So we can close our square bracket. And in the second one, we have the same thing, however, the signs change. So our square bracket, x plus 1 minus, plus 4. We always have different signs. So are we done with these square brackets? No, it still looks a bit funny. So we can simplify the numbers inside each bracket. Can you guys see that in the first bracket we have x plus 1, let me write this under, x plus 1 minus 4. And in the second bracket we have x plus 1 plus 4. So we have like terms. We have 1 minus 4, which is negative 3. Then 1 plus 4, which is 5. So our final answer will be x, then 1 minus 4, which is a negative 3. In the second bracket, we have our x, 1 plus 4. This time we change the sign. 1 plus 4 is 5. So this is your final answer. That is your fully factorized answer, and that is how we deal with the difference of two squares. Thank you guys for watching. Please like and subscribe. If you need more examples, you can always drop a comment or text us on WhatsApp. I'll see you guys in the next lesson.